Hello, and welcome to the lecture on 2.5. Today we're going to talk about linear function models. Now, let's start with a linear function again. A linear function is a function of the form f of x is equal to mx plus b. The graph of a linear function is a line with slope m and y-intercept b. Now, we've seen these before. We've actually dealt with them quite a bit. Let's go ahead and do an example to determine what kind of functions are linear functions. Determine which of the following are linear functions. A, y minus 3 equals 4 times x minus 2. B, f of x is equal to 2 times 3 minus 4x. C, g of x is equal to x times 3 minus x. And D, h of x is equal to 3 minus 4x over 2. So let's start with A. Now, A has a weird form because we don't have an f of x or g of x or h of x anywhere, but we have a y. It's still the equation of a line. So if we replace y with f of x, then we have a linear function. B, this one should be pretty obvious. If you distribute this 2, then you have f of x is equal to negative 8x plus 6. So negative 8 would be your m, 6 would be your b. So we clearly have a linear function here. C might be a bit tricky, but it's actually not a linear function. The reason it's not a linear function is if we distribute this x, then we end up with an x squared term here. But f of x has to be in the form mx plus b. There is no x squared term in a linear function. So g of x is not a function. And D, h of x equals 3 minus 4x over 2. This is actually a linear function. What you would want to do in this case is separate the numerator. Have 3 over 2 minus 4x over 2. Now remember, when you add fractions, they have to have a common denominator. And when you do add them, the denominator doesn't change. So 3 halves minus 4x over 2 is the same thing as what we have for h of x. Now if we reduce, we end up with 3 halves minus 2x. Now this negative 2 would be your m, and 3 halves would be your b. You would have h of x is equal to negative 2x plus b, which is 3 halves. So this is actually a linear function. Okay, the next topic we're going to discuss is the relationship between the slope and the rate of change. So let's start with the function f of x equals mx plus b. Now recall, the slope in this function is m, and m is bound by y2 minus y1 over x2 minus x1, whenever x1, y1 and x2, y2 are on the curve. So we have this slope. Now remember also that when we have a function like this, f of x is your y variable. So if we were to graph something, it would be y equals f of x. This is what we're graphing. Y is the output variable upon inputting an x variable. Right? Now, so what this means is that y2 is equal to f of x2, and y1 is equal to f of x1. Now, using this and replacing our y2 and y1 in our slope equation, we get the following. M is equal to y2 minus y1 over x2 minus x1, which is the same thing as f of x2 minus f of x1 divided by x2 minus x1. Now you might recall that this is the rate of change. So we end up with the slope of a line is equal to the rate of change of the same line. So m is both the slope and the rate of change. And this should make sense. When we have the equation of a line, something like this, as our x increases, our y is also increasing or decreasing according to the slope, but is increasing or decreasing at a constant rate, meaning that if x changes a certain amount, then y changes some multiple of that same amount. For the linear function f of x is equal to mx plus b, the slope of the graph of f and the rate of change of f are both equal to m, which is the coefficient of x. M is equal to the slope of f equals the rate of change of f. I want you to try one now. The separatists lay siege to the Ryloth forces, cutting up all food and supplies. The amount of food in kilograms remaining on day t is modeled by f of t is equal to 2000 minus 700 t. A, what is the slope of this function? And B, at what rate is the amount of food changing? The next topic of discussion is going to be making use of linear models. I want to make a note here very quickly. Now, I know we just talked about this, but I want to make this note anyway. When a linear function is used to model the relationship between two quantities, the slope of the graph is the rate of change. So in these types of problems, you're going to come across a rate of change in the problem. That's what your slope is going to be. Example. Grievous is injured and leaking lubricant. If the lubricant is leaking at a constant rate of 3 milliliters per hour, and he had 1,000 milliliters of lubricant initially, find the linear function that models how much lubricant Grievous has remaining after t hours. Grievous is leaking 3 milliliters per hour. So this is actually going to be our rate of change, which is going to be our slope. And he had 1,000 milliliters to start. Now, the question is, we're trying to model the volume of the lubricant that he has remaining. He's losing 3 milliliters per hour. So we had 1,000 initially, and we're losing 3 milliliters per hour for t hours. We're looking for how much he has remaining after t hours. So 3 times t will give us a quantity in milliliters that he's lost. He had 1,000 to start with, so this will be v of t, the volume. Now, with the rates of change, you have to be careful. In the problem, it's not going to state whether it's a positive value or a negative value. You have to infer that from the context of the question. He's leaking lubricant means that we are losing volume. So it's going to be negative. Now, if he was, say, refilling his lubricant, then that would be a positive 3 because he would be adding lubricant to it. Now let's suppose that we wanted to know how long it would take for him to be completely empty, for no more lubricant left. Well, all we need to do is figure out what that means in the context. So if we're in the context of this question. So if we're looking for the time it will take for there to be no more lubricant, that means that the volume of the lubricant remaining would be 0. So if we wanted to know how long it would take for him to be empty, we would have 0 equals 1,000 minus 3t, add the 3t over and divide by 3, and we get t is equal to 1,000 divided by 3. This is how long it would take for him to lose all of the lubricant. Okay, I want you to try one now. An X-Wing is being refueled. Suppose the X-Wing already has 6,000 liters of fuel and the crew is refueling it at a rate of 50 liters per minute. A. Write an equation to model the volume of fuel in the X-Wing. B. How long will it take for the X-Wing to be full if the max fuel capacity is 30,000 liters? All right, that's going to be it for today. I will see you all at the next lecture.